All right, so before we jump into the routing, a couple of miscellaneous things popped up. Some questions on the trunks themselves, encapsulation items. With the ASA, the encapsulation is .1Q. Looking at the switch itself, the corresponding switch port does need to be set as a .1Q trunk. Okay, so looking at the connection on switch 1, and pull up our relevant configuration here on switch 1. Is on switch 1 our connection for the ASA to the Ethernet 0/1 interface is set as a .1Q trunk. Other possible things did mention the possibility of an issue of the trunks between the switches themselves. So in this case, looking at the trunk between the switch here, the FA023 port configured as an ISL trunk between the switches. So interface trunk showing us both the configured trunks as well as any negotiated trunks. In this case, port FA013, which is where it's connected to the ASA. We also have port FA023 connecting to the other switch. For each of these, we do have VLANs allowed on the trunk, allowed and active in the management domain, and also VLANs in spanning tree forwarding state and not pruned. So a couple slightly different things here. First off, we have VLANs allowed on trunk. In this case, getting into being able to have administrative restrictions. If you don't want certain VLANs to be able to pass on that trunk, you can get more granular with those. For example, on the FA013, we do have just the DMZ interface and the inside interface. So we could go ahead and make adjustments on that switch port itself. So on the interface FA013, switch port trunk allowed. And looking at our options here, in VLAN, we can specify all, none, or we can add on to an existing or possibly remove from the existing. So if we start off, currently we're allowing all. Change that to none. Looking at the output of our show interface trunk again, in this case showing that we're not allowing any VLANs across that trunk. Again, looking at the switch port itself, the switch is still negotiated as, let's have it configured as a trunk itself. It's configured, not negotiated. The ASA is not going to negotiate the trunk. It does need to be statically configured on the switch side. In case it was configured. But then the VLANs allowed, being able to get into other administratively allowing or not allowing certain VLANs. In this case, we want to change that. We want to say we want to allow VLAN 10. You can do switch port trunk allowed VLAN 10. And take a look at our output here again. Again, now it says we have VLAN 10 is being allowed. Now if we take this and we just say we want to allow our other VLAN here, we want to allow VLAN 125. So switch port trunk allowed VLAN 125. If I look at my output again here, in this case it removed the 10 and replaced that with the 125. If I want to have multiple items, I need to put it in as a add item. In this case, just putting in 125 isn't going to add to the existing, so I have 125 there. I can add 10. My output again. And my output now shows both VLANs 10 and 125. Other questions coming up. Would the type of encapsulation be within the scope of troubleshooting? Definitely could be within the scope of troubleshooting. It could have a subinterface that's not working properly. So it could have an issue where the encapsulation's not properly set or the trunk is not negotiated there. So it could be looking like a access port, or it could be that it's misconfigured on the switch side. In addition to that, it could potentially go back to what we talked about with the core knowledge section. So with the core knowledge section, I could show you the output here from show interface trunk, and I can show you a topology diagram that has the ASA connected to port FA013, and I could say that the ASA has subinterfaces for VLANs 10, 20, and 30. Will that traffic be allowed to pass? So you'd have to be able to determine why the traffic is or isn't allowed to pass. Different types of things, different ways things could be asked. So beyond the allowed on trunk, we also have the allowed and active in the management domain. So just because I have a VLAN allowed on a trunk, in this case the FA023 has 1 to 4094. That's a lot of VLANs. But just because those are being allowed there doesn't necessarily mean I have those defined. The management domain, looking at these here, gets into a subset between what's allowed on the trunk and also what VLANs I have configured on my switch. If I do a show VLAN brief, I can also do show VLAN, but show VLAN brief, a shortened version, shows me what VLANs I have defined on my switches. And if I have ports in those VLANs, it shows me what ports are in those VLANs. Now with that, I have a number of them here. Some of them are just defined and not being used currently. Some have ports in there. For items like a trunk, in this case port 13 was there as a trunk. Port 13 is not showing up as a port on these VLANs. So even though port 13 has the ability, based on our configuration up here, so port 13 can do traffic for VLANs 10 and VLANs 125, it doesn't show up in this output as being on every single VLAN. But you don't necessarily want your port to show up, but you have to know that it can pass traffic. If for some reason we had forgotten to define VLAN 10, VLAN 10 wasn't defined on the switch, even though our trunk's configured properly, then not able to pass traffic for that. So looking at that second grouping there, beyond being allowed on the trunk, the static, administrative, whether or not it's allowed on the trunk. Next one looking at allowed and active in the management domain. Now the next section we have here, VLANs in spanning tree, forwarding state, and not pruned. For the scope of the lab, probably not an issue, but could still potentially run into issues with spanning tree and pruning. Pruning basically blocking off and not taking advertisements for VLANs that you don't have defined locally. Depending on how those VLANs are set up, you may need to look at things like that. In this case, we do not have anything that's not being pruned. Kick back to our output again here. Refresh this. So in this case, VLANs in spanning tree, forwarding state, and not pruned. So we have on our FA013, we had some other administrative restrictions, but we have 10 and 125 there. Those are not pruned off, and our other VLANs here. Again, if you're having problems traffic passing for a VLAN, the switch is definitely a place to look. So going back to our topology side of things here, we have router 2 and ASA 1 on this VLAN 122. Those connections could be on the same switch. Those could be on two separate switches. If those connections are on the same switch, then shouldn't be any issues connecting on that switch as long as that VLAN is defined locally. If those happen to be on two separate switches, then additionally the trunk between those two could potentially cause problems. As far as additional troubleshooting or testing, if I did have a situation here where ASA 1 and router 2 were on two separate switches, and I wasn't sure if it was a problem with the configuration there or a problem with trunk itself, one thing you can do for testing purposes on the switches themselves, if they're not an active device doing other routing as a layer 3 device, you can just take and add in a SVI interface. If I added an SVI interface on, say, switch 1 and switch 2 in VLAN 122, I could then test and ping. Can I ping from switch 1 to switch 2 on that VLAN? Can I ping from the ASA to switch 1 or from the ASA to switch 2? And being able to troubleshoot where the connection is. So if I have ASA 1 is connected to switch 1, router 2 is connected to switch 2, and I can ping from ASA 1 all the way through to switch 2, it's getting through switch 1 and through that trunk over to switch 2, something's preventing it getting to R2. May want to focus your efforts more on the router 2 side. Additional items, if you do go putting in things like that, putting in SVIs for testing for local interfaces, I generally recommend removing those unless that device is not doing any layer 3. If that device is just doing other VLAN stuff and that's not going to affect things, that's fine. In this topology that we have, our earlier topology diagram, we do have switch 1 and switch 2 are acting as part of the device. If I did just go add interfaces on device, that could short circuit things. If I'm trying to do a LAN-to-LAN VPN, for example, and I happen to have the other network locally connected, he's going to route that locally instead of passing it potentially through devices that are doing encryption. So your devices are doing other layer 3 functions. Generally, you can put in for testing, but remove it afterwards if they're not. And again, if you're not sure, double check with the proctor if you need to remove that type of configuration at the end. So again, look at your switches, check your switch ports. If you are having troubleshooting issues, take a look at your switches themselves. In addition to that, things like port fast, again, some people will put on all their ports for their devices, for the routers and firewall devices. The ASAs, again, it does do a .1 queue for the encapsulation. Make sure your switch is properly set up as a trunk port. Now, with a .1 queue configuration, we also have, looking at our options here, on our trunk itself, we have what's called a native VLAN. Does everyone know what the native VLAN does, how that affects things? Got some basic answers of yes, I know what it does. Okay, the native VLAN itself, by default on these switches, the native VLAN traffic is going to be untagged. Now in this case, that happens to be VLAN 1. Talk a little bit more about VLAN tagging a little bit more later in the week and some of the miscellaneous security attacks. But the traffic for the native VLAN itself is passing untagged. So on the switch itself, looking at the connection on the router itself, or the firewall, in this case, the firewall is passing traffic on the 0/1 on the 0/1.10 and the 0/1.125. Now, we could potentially also use the main physical interface. We could use the Ethernet 0/1 interface on the ASA, even though that interface also has sub-interfaces. So you could potentially use both the physical interface and sub-interfaces on the same physical interface connection. If you were in a situation like that, the traffic on the physical interface itself is going to be untagged. The traffic passing out for the physical interface itself would be untagged. Traffic passing for the DMZ in this case is VLAN 10 .1 queue tagging. Traffic for VLAN 125 being a .1 queue tagging there. It could potentially, what's currently the outside on a separate Ethernet 00 could potentially be Ethernet 0/1 and just passing untagged. Now, if it was passing untagged, then we would need to adjust the corresponding native VLAN on the switch match, in this case VLAN 122, so that it's matching that. But you do have the potential of also using possibly native VLAN. And if you have a native VLAN configured when you're dealing with a trunk, your native VLAN is what your physical interface would use because your physical interface is passing traffic untagged. Any other general questions on trunks, trunk configuration verification, VLAN verification? Between your two devices, we do also have VTP modes. So VTP status. In this case, showing running VTP1, VTP2 capable. Currently showing this particular switch happens to be in transparent mode. Configuration revision of 0. And other miscellaneous VTP options listed there as well. General options for the switches themselves, you know the option of server mode, client mode, or transparent mode. Transparent mode, keeping the information locally. Server and client. Server passing updates, clients receiving updates and accepting those, assuming they have the same domain and password configured. BTP versioning, most likely would see version 2 in the lab. For the scope of the lab, there has been discussion there may be additional switches. In the past, it was explicitly stated as 2 switches. In some of the more recent discussions, they have stated there may be more than 2 switches. So it is possible that they will have 3 or 4 switches, not necessarily just limited to 2 for the scope of the lab. In the event you did have multiple switches, you would need to make sure to double check where your traffic is passing through. So with 2 switches, it's pretty straightforward. It's going from one to the other. With 3 switches, it's possible if I'm going from switch 1 to switch 2, depending on how things are set up, I may logically end up going from switch 1 through switch 3 and then to switch 2. In that case, that gets into other things like how my spanning tree is set up, where my spanning tree root is, and that can affect where the VLANs are as well. So looking at where VLANs are, in that case, VLANs would need to be defined on all 3 switches for the traffic to smoothly pass. So we got their interfaces. We checked our stuff on our switch. Verification information. Moving on, next part we're going to look at is routing and routing configuration on the devices. Different routing options. Static routes, RIP version 1, version 2, OSPF, EIGRP, different types of things that can be done for routing as far as the CCIE lab goes. So starting off, we're going to start with a basic setup here on our ASA routing. And start off basic setup on ASA 2. On ASA 2 here, we have our static routing setup. We're going to configure static routing connecting to router 3, and then configure RIP between ASA 2 and router 6. Go over to the ASA. Now routing done slightly different on a router being done with the IP route statement, on the ASA with a route statement followed by the interface. So route, in this case, leading to the outside. And the network that we're looking at, in this case, we're going to do it for the loopback of router 3. Check, make sure you get that correct. IP interface brief. In this case, our loopback 0, 150.1.3.3. Now in this case, we're told to do a static for router 3's loopback. For the static itself, we could use a exact match, or we could double check what the actual subnet is used on the loopback itself. Got address mask and the gateway. In this case, the gateway is our interface connecting to router 3. At this point, able to ping router 3's loopback. We have a route for that. We can also just look at our route information and show route on the ASA, showing we have a static route via the outside on that interface. Next, we're going to configure RIP version 2 for our connection to router 6. And RIP using major networks, so we only need to put in the classical network boundary there. Rolling back up for the router RIP, specified our version, specified our network information, and we have a RIP process running from the ASA talking to router 6. RIP being two unidirectional flows, one from ASA to router 6 with its advertisements, one flow from router 6 to the ASA. Again, the traffic terminating on the device different than traffic passing through the device. In case traffic terminating on the ASA, the RIP advertisements, listening on those based on the network statements. In case having the network statement 150.1.0.0, enabling the ASA to listen on that interface. Do not need to have access list entries or other entries for that. If it was, say, an outside interface, you don't need to have explicit entries for that because it's the routing advertisements are terminating on the device. RIP uses link local 224.0.0.9, or potentially if it was a unicast configured with a neighbor statement under the process, would be unicast to the address of the ASA itself. Okay, so we've got a basic configuration, basic setup here. We got RIP information there being passed on. Take a look at router 6. And looking at router 6, we do show that router 6 shows a route there for the 150.1.39.0 network learned via RIP. Because RIP does use the classful networks, because the other network on the other side happened to fall under the same major classful network 150.1.00/16 that did get advertised to router 6. So on router 6 now, if we try and ping this device, ping 150.1.39.3, will this ping be successful? In this case, we have a ping traffic that is not successful. A couple of reasons why. Take a look at router 3. Could be routing potentially. But we are getting messages from that side, so it's not routing issue. Verify router 3 has an issue, has a network for that. Router 3 here not having a turn logging off. Other MD5 errors for BGP there. Make sure that router 5 or router 3 has a route. We're going to go ahead and just add a route on router 3. Back out later, but we're just adding this for testing now. Try our connection from router 6 again. Kick off that ping. It's not successful in the ping still. What happens if we try something else? Try to ping, ping wasn't successful. Other traffic, we'll try telnet. Now telnet we're able to connect, but ping we're not. What's the difference between ping and telnet? Why are we able to connect with one and not the other? We have routes there, we have routes back. Okay, we have different traffic types here. So different traffic types, one being TCP, one being ICMP. In this case, getting into some of the defaults as far as behavior items on our devices. In this case, these devices do have a firewall in the middle, ASA2 there, acting as a firewall. Looking at information, what information is allowed, not allowed. In this case, getting into the defaults for looking at traffic and various inspection information, looking at traffic, watching traffic, putting it into that state table, looking at the connections. Switch to router or ASA here in the middle. And we're just going to do a show connection. Looking at what we have our show connection here. We also have show connection detail. Again, different types of items depending on where the traffic came from, who originated traffic, where it's coming from, where it's going. In this case, looking at our connection item. In this case, here we have just a show connection giving us brief information, show connection detail, getting into a little bit more, keeping track of information as well as giving some other explanation as far as the flags themselves. In case I have flags of U, I, and O. So I have I for inbound, O for outbound, and the U being the up. My connection is currently up, inbound and outbound. So if we switch to our ASA here, and we're going to do the big no-no and put a wide open access list on it. They permit IP any. And put that in on the outside interface. Now in this case, we have a very scary wide open access list. Do not do this in production environments unless you have absolutely no other way to do it. Moving back to router 6. Getting additional messages here now. Exit out. To router 3. Verify that you can ping through. Case able to ping through. Also, we're going to try telnetting through from router 3. Back to the ASA, looking at our connections. So we have some different connections here, different connection information. Taking a look at the information we have two separate connections here we're seeing. First one showing TCP outside. We have a address, port, address, and port. In this case, connecting port 23, high numbered port. We also have a separate connection here that happens to be BGP, inside and outside, setting up their connection. Again, flag information here. Looking at our flags before up here. Here we had UIO for our flags. And here on this one, we have UIOB. The difference between these two, in this case also including the B, showing that the initial SYN was from the outside. So whether the connection came from the outside or whether the connection was initiated by the inside, additional information being kept on the ASA. For the scope of the lab, again, going back to things like the core knowledge, this is the type of thing that you could get asked. You could get asked, where did the connection get originated from? Who's the connection to? Things like that you can see from the output of these show commands. You could just be given some show command output and asked to describe what you can about that particular connection. Now you may get the flags. They may just also just do a show connection without the detail, and you would have to know what those flags meant. Again, I wouldn't expect them to have you know every single one, but generally the more common ones, inbound, outbound, where it originated, types of things that you should know. Now, in this case, we did an access list to allow that traffic. If we switch back to router 6, try to set up our ping again. Able to ping through the firewall. In this case, because the TCP traffic being looked at by default, ICMP being separate information there, not TCP traffic, not UDP traffic, separate IP protocol. So being treated slightly different. On the ASA itself, we do have other options here. We're going to go ahead and take off that access list. Back to router 6 and try this ping again. And the ping fails. We did mention the ability of additional policy information. Looking at our policy, we do have a global policy in here as well. We have a global policy matching any default traffic, different items that are being inspected by default. So in that, we do have various inspections. Go ahead and jump into that policy. And various inspection options here. We're going to go ahead and look at our inspection options here. Variety of different traffic. In this case, we're just going to look at ICMP. We're going to go ahead and add on ICMP inspection. ICMP inspection on the ASA, looking at traffic, still have to pass your basic rules inside to outside with the security levels, or if it goes in the other direction based on access list. It's coming from the outside. In this case, with an ICMP inspection on, even though we do not have the access list on the interface, we will be able to ping through. So kicking off our ping again, our ping is successful. In this case, the ASA itself looking at that connection information. Try to ping from router 3. Connection. Router 3 itself not able to ping because he doesn't have the appropriate rights on the firewall. It doesn't have access to entry to allow that inbound or the existing entry in there. The ICMP inspection, allowing it still from the higher to lower security level, but not having the wide open hole for that ICMP traffic coming in. Also being restrictive about ICMP traffic. Just because you have the inspection on and someone sends out a ping doesn't mean I'll be able to send a flood back of ping responses. It's still restricted to only taking the first response back. So not taking a wide open response on that. Other miscellaneous options we have, we do also have on the router itself, on the firewall itself, the ability to look at specific items. So we can look at items on the firewall itself. We have a couple different options we can use. We can use packet tracer, and we can also use the capture command. So look at the capture, call it test, and say we want to do interface, the outside, and in the newer versions, we do have what's called the real-time option that will show you traffic in real time. I can watch traffic coming in to the interface itself. Again, in production networks, could be a very bad thing if you are pushing at console speed. Now at this point, we're just trying some pings from router 3. In case we're not allowing those, but we can see those requests hitting the outside interface of the device itself. Again, not allowing that traffic in, but looking at the capture command, able to see what happens, able to see that traffic coming in. Okay, seeing those individual echo requests coming in. Now, cancel that on router 3. In this case, I was looking at the outside interface. I could also look at the inside interface as well, but just additional ways that you can look at the traffic. And we'll look at that a little bit more later on going through troubleshooting. And at the end, you will get a summary of what packets was shown and not shown. I'm going to go ahead and just turn that capture off. In case nothing was restricted because of the performance there. We're going to switch on to our next part here on our device itself. Next up on our router here, we're going to switch over from a static configuration, getting into a dynamic configuration. We're going to add some OSPF in. Any questions on RIP configuration on the ASA? For the most part, pretty straightforward. Just like a router, have a network statement. You can also get into things like passive interface. If you want to not send updates out or just receive on an interface. It does use classical networks. You can do unicast with a neighbor statement with a passive interface as well. Different, fairly straightforward as far as RIP goes. Most people don't have any issues or problems with that. Next, we're going to look at OSPF here. In this case, basic OSPF configuration on the ASA connecting to router 3. Those of you that have configured OSPF on a router, differences being the mask is reversed from what it would be on a router when configuring on the ASA. The router OSPF, the network statement, and also specifying an area. In this case, we're told area 0. The OSPF area 0 being the backbone area. Again, if you did have other areas, you could run into situations like a stub area. Just show route here. We do show we're receiving some routes here. Go ahead and remove our static route that we had for our loopback. We also learned that by OSPF. We did learn that loopback by OSPF once we had the static route. Again, the static route taking preference due to the administrative distance. We could have configured a higher level on our static route, in this case defaulting to 1 for the administrative distance. Default administrative distance for OSPF being 110, RIP being 120, different for the different protocols. So now we have different route information here. Take a look through on other devices. Take a look at router 6. And router 6 receiving the route from the ASA for the network on the other side between ASA 2 and router 3, but not receiving other networks. In this case, multiple processes on the ASA by default being kept separate. In this case, I want to bring those two processes together. What do I need to do in order for router 6 to see those other routes? In this case, we need some basic redistribution on the ASA, redistributing between the two processes. In this case, happens to be OSPF and RIP. We could potentially have two separate OSPF processes, or potentially OSPF in the same process with either the same area or different areas. Talk about those in just a second. For now, we're going to get our basic redistribution going. And we're going to go ahead and just redistribute, add in a metric, redistributing into RIP. The metric of 3. And if you try and redistribute into RIP, with just redistribute RIP, you will get an error message, only classful networks. When going into OSPF, make sure you do have the subnets keyword specify. Otherwise, you're only going to get classful networks. More than likely, you're not going to be dealing with just classful networks in a lab exam or practice lab exam. Now moving on to router 6. Take a look at routes being learned. Now we have a lot more RIP routes being learned. So router 6 having a lot more visibility into other parts of the network. Now in this particular case on the ASA itself, we did have two separate routing processes configured, OSPF and RIP. And we did just do a basic bidirectional redistribution, which meant we redistribute the routes from OSPF into RIP, and we also redistribute the routes from RIP into OSPF. With separate processes running for separate interfaces, you may or may not want to do that. It's possible that, say, the outside of my device could be facing the internet, and I don't want to be passing my internal routes. I may just want to have a default route out, and the provider may have some other specific routes to get to me on their end. So you could potentially have redistribution just in one direction, or you could, as we did here, have it in both directions, from one process to the other, and vice versa. Not automatically going to go in both directions. If I want RIP routes in OSPF and OSPF routes in RIP, I need to manually put in both those redistribute statements. Beyond that, you can get into other filtering with the redistribution, things like that. I strongly doubt that they would get too much into that for the scope of the security lab. Again, just different things you should be familiar with. OSPF, dealing with areas. So areas and having to have a connection to area 0 if you have area 0 present. So in this case, we have area 0 here on device. If we had area 0 was split up, or we had other areas, we may need to look at things like virtual links. In this particular case, in this topology, not an issue. Area 0 connecting and then having other areas off on the side. If you do have multiple areas on the ASA, in this case, instead of being RIP version 2, if that was, say, OSPF area 2, those could still be in the same process. It'd just be a separate network statement for that inside interface in that case. Now, alternatively, it could be done as two separate processes. So I could have OSPF 1 on the outside interface and OSPF 2 on the inside interface. In that case, it'd be two separate processes running independently. If I wanted routes from one or the other, would need to get to additional redistribution passing routes between the two OSPF processes. So different types of things, different possible setups. There is also the possibility of getting into EIGRP. In this particular example, not getting into EIGRP. For the most part, EIGRP very similar to OSPF, except that you don't have to have the area specified. You don't have to have the area specified. It's a lot more straightforward. Again, the masks are inverted from what they usually are on a router. So having the mask instead of the wildcard mask. Other than that, fairly straightforward. Beyond that, other general features to be familiar with. OSPF, be familiar with things like virtual links. What are virtual links? Where do you need virtual links? As EIGRP, familiar with some of the more common topics, things like EIGRP stub areas and things like that that can be configured on the security devices. All right, so we're going to go ahead and move on to our other ASA here. I'm going to configure on the ASA 1, basic setup, RIP on the DMZ, and then OSPF on the inside and outside interfaces. We're going to go ahead and do some redistribution as well. Change our host name here as well. Router RIP, setting our network and setting our version 2. OSPF. Area 0 on our outside interface, area 100 on our inside interface. Again, getting into a basic redistribution. Redistribution from RIP to OSPF, from OSPF to RIP. Look at what routes we have. See who we're learning routes from. In this case, We have routes learned via 151, 122.2, which is router 2. Those are OSPF routes. Those are showing up as E2, which means those are redistributed into OSPF somewhere else. The routes we have some OSPF routes being learned from the 125.5, which would be router 5. Routes for both of those. We're going to RIP information and show our RIP database. Verifying we do have those routes. We do show our routes redistributed into RIP. In this case, we happen to have our AAA server on the interface, showing we have those routes redistributed in, and also showing that they have the metric value applied. We got our routes, we get redistribution set up. Networks passing between our devices. Again, with multiple processes, may need to be restricted as far as what you're allowing or not allowing in certain places. For the most part, we appear to have general connectivity. We can try telnetting or connecting from one side to another. We're going to get into access list next. Before we do that, are there any other questions on the routing protocols?